everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem 2d square minus 7d plus 3 into y equals to sine square x. Firstly, let's find order and degree of the given differential equation. Identify the highest derivative here. D square is the highest derivative, so order will be 2. And the highest power of the highest derivative is the degree. Degree is 1. Or just write the given differential equation as 2d square y minus 7dy plus 3y equals to sine square y. We know that d is a differential operator. Then d square will be d square by dx square. Now we can write our equation as 2 into d square y by dx square minus 7 into dy by dx plus 3y equals to sine square x. Here the highest derivative is d square y by dx square, so our order will be 2. And the highest power of the highest derivatives are degree. Degree is 1, right? Now coming to the problem. We are given a differential equation. Given differential equation 2d square minus 7d plus 3 into y equals to sine square x, which is in operator form. F of d into y equals to q, where f of d equals to 2d square minus 7d plus 3 and q equals to sine square x. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is a complementary function and yp is a particular integral. We'll find yc using the roots of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Simply taking RHS to 0, we'll get the homogeneous equation f of d into y equals to 0 to the given non-homogeneous equation, and we'll find yp using 1 by f of d into q. So firstly, let's find complementary function using the auxiliary equation. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we have f of d 2d square minus 7d plus 3, right? Let's replace differential operator d by m, then we'll get f of m equals to 2m square plus 7m plus 3. Now our auxiliary equation becomes 2m square minus 7m plus 3 equals to 0. So we'll find roots in two ways. Split minus 7m as minus m minus 6m. Now take m common from the first two terms, we'll get m times 2m minus 1. And take minus 3 common from the next two terms, we'll get minus 3 times 2m minus 1, right? Minus 3 into 2m is minus 3 into 2 minus 6m, minus into minus plus, 3 ones are 3. Now take the common factor 2m minus 3 common. We'll get 2m minus 1 into m minus 3. Equate each factor to 0. Then we'll get m equals to 1 by 2. And from m minus 3 equals to 0, we'll get m equals to 3. Then m equals to 1 by 2 and 3 are the roots. Or we can just use quartic form to find the roots. Simply compare this equation with quartic equation. Then for a equals to 2, b equals to -7, c equals to 3. We'll use quartic formula minus b plus or minus square root of b square minus 4ac by 2a minus of b minus 7 plus or minus square root of b square minus 7 square minus 4 into 2 into 3 by 2a is equals to 7 plus or minus square root of 7 square is 49 minus 4 into 4 2s are 8, 8 is 24 by 2 2s are 4, which is equals to 7 plus or minus square root of 49 minus 24 is 25 by 4. Then m will be 7 plus or minus square root of 25 is 5 by 4. You can write it as 7 plus 5 by 4 and 7 minus 5 by 4, or right, which is equals to 7 plus 5 is 12 by 4 and 7 minus 5 is 2 by 4. 4 3s are 12, 2 2s are, is equals to 3, 1 by 2, right? You'll get the same thing. So m equals to 1 by 2 and 3 are the roots of our auxiliary equation. Therefore, m equals to 1 by 2, 3 are the roots of our auxiliary equation, which are real and distinct. We know that when two roots are real and distinct, we write complementary solution as, or complementary function as, one constant into e power 1 root into x plus the other constant into e power at the root into x. Now, our complementary solution will be like complementary function y is equals to constant into e power 1 root into x plus the other constant into e power the other root into x. Then y is equals to c1 e power x by 2 plus c2 e power 3x. Now let's find particular integral. We can find particular integral using 1 by f of d into q, where f of d is 2d square minus 7d plus 3 and q is sine square x. We know that cos 2 theta equals to 1 minus 2 sine square theta, right? Or 1 minus 2 sine square theta equals to cos 2 theta, right? Now, bring this cos 2 theta to LHS and take 2 cos sine square theta to RHS. You'll get 1 minus cos 2 theta equals to 2 sine square theta. Now bring this 2 to LHS. We'll get 1 by 2 into 1 minus cos 2 theta into, 1 minus cos 2 theta equals to sine square theta. Now for theta equals to x, we'll get sine square x equals to 1 by 2 into 1 minus cos 2x, right? So, replace q by 1 by 2 into 1 minus cos 2x. Now we can write this as, take the constant 1 by 2 outside, we'll get 1 by 2 into 1 by f of d into 1 minus cos 2x. Then yp becomes 1 by 2 into 1 by f of d, 1 by 2d square minus 7d plus 3 into 1 minus 1 by f of d, 2d square minus 7d plus 3 into cos 2x. See, here we are having 1 and this is of 1 by f of d into some constant. So we'll write it as, or we'll write it in 1 by f of d into ax form. For a equals to 0, we'll get e power 0x, which is e power 0, 1, right? Since e power 0 is 1, so we can replace 1 by e power 0x. We'll get 1 by 2d square minus 7d plus 3 into e power 0x minus 1 by f of d, 2d square minus 7d plus 3 into cos 2x, right? If you want, you can name first term as yp1 and second term as yp2 and find yp1, yp2 separately. Let's find yp1, 1 by f of d into e power 0x. So this is of 1 by f of d into e power ax form, right? We have f of d 2d square minus 7d plus 3. Let's find f of a. Now compare e power 0x with e power ax. Then for a equals to 0, we'll find f of 0 is equals to 2 into replace d by 0. We'll get 2 into 0 minus 7 into 0, 0 plus 3 is equals to 0 plus 3 is 3, non-zero. Since f of 0 is non-zero, so we can replace d by 0. Then we'll get 2 into 0 square minus 7 into 0 plus 3 into e power 0x is equals to 1 by 0 plus 3 into e power 0x, which is equals to 1 by 3 into e power 0x is e power 0, which is equals to 1 by 3 into 1 equals to 1 by 3. Since e power 0 is 1, so we'll get e power 0, 1 here, right? Therefore, yp1 equals to 1 by 3. Now let's find yp2, 1 by f of d into cos 2x. This is of 1 by f of d into cos ax form. Now we need to find d square, which is given by minus a square. Then for a equals to 2, we'll get minus 2 square equals to minus 4. Now let's see what happens by replacing d square by minus 4 in the denominator. The denominator must be non-zero. If the denominator becomes 0, we'll get something like this. 1 by 0 into cos 2x. Since 1 by 0 is undefined, so the total term becomes undefined, right? So take the denominator part and replace d square by minus 4. We'll get minus 2 4s are 8 minus 7d plus 3 equals to minus 8 plus 3 is minus 5 minus 7d, which is non-zero. Since we get non-zero by replacing d square in the denominator, so we can replace d square. And this becomes 1 by 2 into minus 4 minus 7d plus 3 into cos 2x is equals to 1 by minus 2 4s are 8 minus 7d plus 3 into cos 2x. This becomes 1 by minus 8 plus 3 is minus 5 minus 70 into cos 2x. Now take minus common from the two terms of denominator. You'll get minus of 5 plus 70 into cos 2x, which is equals to minus 1 by 5 plus 70 into cos 2x. See, in the denominator of the fraction we have 5 plus 70. Now change the sign. If you change the sign, then you will get 5 minus 70. So let's multiply 5 minus 70 and divide my 5 minus 70 to this fraction. This becomes minus 1 by 5 plus 70 into multiply and divide 5 minus 70 to this fraction into cos 2x equals to minus 1 into 5 minus 70 is 5 minus 70 by 5 plus 70 into 5 minus 70 into cos 2x is equals to minus of 5 minus 70 by, see the denominator is of a plus b into a minus b form, we can write it as a square minus b square. Then we'll get 5 square minus 70 whole square into cos 2x. This becomes minus 5 minus 70 by 5 square 25 minus 70 whole square, 7 square d square, 7 square is 49 into d square into cos 2x. Again, d square appears in the denominator, so let's see what happens by replacing d square in the denominator. The denominator must be non-zero, right? Replace d square by minus 4 is equals to 25 plus 49 into 4. 4 9s are 36. 4 4s are 16. 16 plus 3, 19. 196, right? It is 221 non-zero. Since the denominator is non-zero, by replacing d square by minus 4, so yp becomes yp2 becomes minus of 5 minus 70 by 25 minus 4 into, this is 49, right? 49 into minus 4 into cos 2x is equals to minus 5 minus 70 by 25 plus 49 fours, 196 into cos 2x is equals to minus of 5 minus 70 by 25 plus 196 is 221 into cos 2x. This becomes minus of, you can just split this as 1 by 221 into 5 minus 70 into cos 2x, which is equals to minus 1 by 221 into 5 cos 2x minus 7d cos 2x. Here d is a differential operator, so we can write it as d by dx cos 2x. Derivative of, here we need to find derivative of cos 2x with respect to x, equals to minus 1 by 221 into 5 cos 2x minus 7 into derivative of cos 2x is minus 2 sin 2x. Then yp2 becomes minus 1 by 221 into 5 cos 2x plus 7 2s are 14. sine 2x. Therefore, yp2 equals to minus 1 by 221 into 5 cos 2x plus 14 sine 2x. Now, coming to yp. Yp becomes 1 by 2 into yp1, 1 by 3 minus yp2 minus 1 by 221 into 5 cos 2x plus 14 sine 2x becomes 1 by 2 into 1 by 3. Okay, here you'll get minus into minus plus, right? I'll remove minus here. Then we'll get plus 1 by 2 into 1 by 221 into 5 cos 2x plus 14 sine 2x. This is equals to 1 by 2 3s are 6 plus 1 by 2 into 221 is 442 into 5 cos 2x plus 14 sine 2x. Which is our required yp. Now we can write the general solution. The general solution is given by y equals to yc plus yp. We have yc c1 e power x by 2 plus c2 e power 3x plus yp 1 by 6 plus 1 by 442 into 5 cos 2x plus 14 sine 2x. This completes the problem. So we have seen a problem from higher order linear differential equations in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.